Hey students, wanted to create this quick video just to go over the quiz just like I did in class. A few of you asked if I would make a video in addition to having gone over it in class just to clarify anything. So hopefully you find this video helpful, and please let me know if you have any follow-up questions. So let's jump into free response. So question 1, it asked, using a simple diagram, explain the difference between a covalent bond and a hydrogen bond, and identify two properties of water that result from hydrogen bonding. So this question's got three components. We need a diagram, we need to explain the difference, and identify two properties. So a sample diagram would look something like this, where I've got water molecules which have a polar covalent bond between oxygen and hydrogen. And we know that oxygen is more electronegative, which is why it has a partial negative charge. If you're lost on how we got that, take a look back at chapter 2. This has to do with electronegativities. Oxygen likes to pull those electrons being shared closer to itself, which makes it partially negative. And the hydrogen, having those electrons pulled away from it, starts to have a partial positive charge. The connection between oxygen and hydrogen sharing electrons in their outermost shell is called a covalent bond. A hydrogen bond is where you have a partially positive hydrogen interacting with a partially negative atom from a different molecule, in this case, an oxygen. And so what I did there is I took the diagram and I explained the difference. Covalent bonds are not interactions between partial positive and partial negative charged atoms. They are two atoms involved in the sharing of electrons. Okay. Now, water likes to have lots of hydrogen bonds with other water molecules. And because of that, there are 5 specific properties that result from hydrogen bonding between water molecules. Those 5, which we went over in one of our first lessons, are cohesion, which is the connecting of water molecules to other water molecules. That leads to things like surface tension. Adhesion, which is water forming hydrogen bonds with other substances. High specific heat, which means that water can absorb a lot of thermal energy without having its overall temperature raise that much. That's what a high specific heat refers to. Fourth, it expands upon freezing, unlike many substances which condense upon freezing. And that has to do with these interactions that form kind of these regular crystal structures. And then lastly, it's a really effective solvent. It can dissolve things really well because it'll pull apart, for example, with sodium chloride, it'll pull apart the positive sodium from the negative chloride and separate them, facilitating the dissolving. Okay, so that's question 1. You got 1 point for the diagram, 2 points for explaining the difference between a covalent and hydrogen bond, and 2 points for identifying 2 of these properties of water. Okay, question 2. These are 3 main differences between DNA and RNA. The first one, again, that many of you got, is that RNA is single-stranded, but DNA is double-stranded, right? The second is that RNA, it has uracil instead of thymine. And uracil and thymine are both pyrimidines, which are single-ringed based nucleotides. And it's just you have uracil instead of thymine when you're building an RNA molecule. And then lastly, on the 2' carbon of RNA nucleotides, you have an oxygen connected to that 2' carbon, but in DNA you don't have a oxygen connected to that 2'. If you are not sure what I'm talking about, refer back to my mini lesson on DNA from last week. So those are the three main differences that I wanted you to put for this question. You got 1 point per answer. Question 3. Question 3 said, take a look at this amino acid, phenylalanine, and you should right off the bat recognize kind of the basic structure. We've got the central carbon, we've got the carboxyl group, and we've got the amine group, or the amino group. And then we have a hydrogen, and the unique part of an amino acid, which is the R group, which is this big ring connected to CH2. That's our R group. And it says, does the R side chain, which is another way for saying R group, appear to be hydrophobic or hydrophilic? And explain your reasoning. And I told you that this is hydrophobic because if you notice, all of the bonds in this structure are carbon-hydrogen or carbon-carbon bonds. And both of those are non-polar bonds. Carbon-hydrogen and carbon-carbon are both non-polar. And what that means is that you are not going to get the partial positive and partial negative charges that you get in a polar bond, which allows for water to interact by forming hydrogen bonds. And so since there's no partial positives or partial negatives on this R group, that's the same way as saying it is hydrophobic, because water literally cannot interact with it. And so this R group is hydrophobic. Okay? So those are your free response questions. I hope that was helpful. Let me know if you have any follow-up questions. Okay, then I went over your multiple choice questions. So just going through these 5. Question 4, water is a polar molecule because a hydrogen atom has a greater electronegativity than an oxygen atom. Well, so as we just saw, that's actually false, right? Oxygen is the one that has a greater electronegativity, not hydrogen. And so this is false. Question 5, dehydration synthesis results in the building of polymers. That's where, for example, 2 monomers come together, like 2 amino acids. So if I have an amino acid plus an amino acid, they get linked together with a peptide bond, and a result of this process is the release of water. The release of water. So you're literally dehydrating the polymer when you form those bonds. You're removing water. So that's the building of polymers. The opposite of dehydration synthesis is hydrolysis. The hydrolysis is the deconstruction of polymers, where you add water to break bonds. Okay. All right, question 3. What type of bond is formed during the formation of a protein? Well, so that was the one I just talked about here. That's the peptide bond. Peptide bond is connecting 2 amino acids together. 7, amino acids differ from one another based on their individual, and this is from our pre-response, R side chains. So every amino acid has a carboxyl and an amino group. The only thing that's different is the R side chain. Question 8, which part of the amino acid is involved in the interactions found in the tertiary structure of a protein? Those are the R groups. The R groups can form things like hydrophobic interactions. They can also form hydrogen bonds. They can also form ionic bonds, but these are happening only between the R groups. The carboxyl and amino groups, these are involved in the secondary structure. And they lead to things like beta pleated sheets and alpha helices, okay, which is why our answer here regarding the tertiary structure is the R groups. So I hope that was helpful. Please, again, let me know if you have any follow-up questions, and I encourage you to review and opt to take that retake. Hope you have a good rest of your evening.